Hey everybody, and welcome to another dev video thing. Now, I'm not going to be streaming this as I kind of just want to chill and code rather than interact with the stream itself. As well, my mental state is already frayed from working on what I'm working on right now. So to kind of explain what I'm doing first before we just dive into it. I've been working on the conveyor belts and assembly line for no particular reason. I just decided that that's what I was going to do with my sleepless night, was working on conveyor belts. The problem with the conveyor belts is they have a ton of render states. Now, I could just ignore all of this and do it the old style way where I literally render the tile and then change the texture, which would have been very few lines of code, would have been really, really fast. But I am trying to make a commitment to doing everything via JSON data. That way, one, I don't have to do it again. And then two, it's customizable by you guys. There's a lot of parts that are coming into play with this conveyor belt. There's a lot of systems that need to be worked on. The setting system is not tested yet. It is implemented, so this is going to be used for both configurations and normal settings as well. So if you guys change like the render data in here, like if you want it to render some different way, you can change the settings so that way the system understands how many frames it needs to render on the model. So this controls actually the number of states for that model as well. But the problem I ran into is when I went to go program the states themselves, because this technically is programming, by the way. Entering JSON data is programming. It's just very strange when you think about it that way. Most people will call it data entry or data creation or something. But we have three types of belts. Now, I'm only going to be focusing on this belt actually for most of this video because I only care about the flat belts working right now. These are the old classic assembly line belts. I decided to go ahead and implement these. Previously, I was working on implementing a Factorio style belt. I know it's weird that I'm trying to mimic Factorio, but I kind of like it the way it does things, and I do plan to implement a lot of content very similar. After all, it kind of feels right that a game that was inspired by my work, I'm inspired by it. I'll tell the story about that later. But to do this, in order to kind of do this, we got three types. Each of these types has so many different states on it. So the flat has 14 states times 4 because it's got rotations on it. That ends up with like 90 something states. Then each of these has like 100 and something. No, wait, less than 100. I think it's like, we'll do the math real quick. Oh, I did not want to click edge. At least it opened fast this time. So 14 states times 4, so our flat one has 56. I think it's the other one that was larger. So this, the other one is 24 times 4. So each of these has 96. This has like 56. So it's a lot of states that I would have to enter by hand, or I would use the existing for loop system. So the existing for loop system actually would have got me through this pretty quickly. I would have only need to make 4 for loops per each one of these, which ended up with 12 for loops. And instead, I convinced myself that this would be nicer. And it kind of is. If I get this actually implemented and working, this would be a really, really cool system because this is there's tons of things you can do with this if this works. So what I decided to do is I'm going to implement for each loops. I said I kind of might not do this. I said I kind of might do this in earlier videos or streams. I don't remember which I did. But the ideal is that we can now go between each of these elements, injecting the data into our map and doing things with it. So we have two of those. So we have one that goes, okay, we're going to do flat, incline, decline, and the number of frames for each. So if you guys do your frame count, you're going to have to, I guess, do your frames this way. I might implement a way to pull setting data so you only have to implement your frames in one spot, but it doesn't make that big of a deal because it's only one spot. It's only really a couple spots you have to do this. Then we're doing another for each loop to do the directions. There's rotation in here right now. We're going to end up doing the rotation as soon as we figure out if this loads or not. And then we actually have our proper data, which does a normal for loop, which then has an endpoint. The endpoint is going to be injected by this up here that tells us how many frames. We have our massive ID thing, which does type, direction, and then number, which is our frame count. And yeah, a lot of complexity is what is in here. To get this to work though, because the previous state system only allowed for one for loop. It did not even support nested for loops. There are other parts of the system that do nested for loops. I think it's limited. I think the only one that actually does allow it is multi-blocks. Texture data is not, even though I actually worked on the wiki here, and I think I said it does support it. If we go to engine, I am working on the wiki. I'll probably put a post about this out later on Patreon for you guys to look at. But the ideal is I'm trying to get this in here. This is mainly for my use, to be honest, so there's going to be a lot of work that this needs to make it usable by you guys. But this is here to remind me how this works, because I forget half the time too. It's not often I actually mess with JSON data. But yeah, we got like example of the multi-block nested system, and we got an example of how the text for data works and stuff, as well as an explanation how this does. I think I mentioned that you can nest these if you do stuff, but I'm going to have to actually work on it more in order to make it work. And that's actually probably what we're going to do mostly today as well, is that I'm going to get the nested system to work for everything. And we are doing that in the JSON render system. So I'm going ahead and I'm building out the demo code to figure out if this is going to work. So for starters, I built a do for loop recursion type of system. So you call this every time you hit a for loop in the system, and it will recurse on itself. It does have a depth check. The depth check will actually prevent it from running, and what will happen is if it comes down to here and it goes, okay, there's another for loop, and then we go if depth is greater than equal than to our depth check, which will put our depth check. We're actually going to put it right here because I'm going to end up moving this code. Int max for loops. Now this would be 100. The reason why I'm doing it this way, for how many for loops we're going to limit towards, is this is actually not designed to prevent you from having 100 for loops. It's actually designed to prevent you from nesting a for loop into an injection key and then causing the system to infinite loop. Because what I was envisioning when I was coding this is that you could figure out a way to inject large sections of code into these keys. It's actually very dangerous the way I've got this set up, and there's a lot of limitations I need to put on this because you could abuse this system. So somebody could send you actually the way this could happen is somebody could put a resource pack. In the resource pack, they could change the render code and they could put a double nested for loop, and they can cause your client to crash on connect and probably even your computer to go down in the process. It's why I need to make sure this is here, and this will just go throw new runtime exception. You're still going to crash, by the way, but at least you won't run out of memory. And this will just go, okay, too many for loops. Too many for loops are building JSON element. The limit is set to so it's going to be 4. Okay, what did I call that? Max for loop count. I should pay attention when I'm coding. Would be useful. Also, probably need to move this mic a little closer. That might help too. And then we'll explain why we did it, so that way somebody doesn't get upset. It's like, oh, why can I have more than 100 for loops? It's because it's to prevent infinite looping. I can't even think of a single case where you would need 100 for loops, let alone like more than 10. It just doesn't make sense to me at all. And speaking of which, actually thinking about that, there's actually eventually down the road, we're going to have to add if statements to this as well. Because imagine you're coming down here and you want to actually change what you're doing in this location. We go like if I equals 3, then you want to switch to a different for loop. That example of using an if statement probably would be beneficial for multi-blocks in structured gen-code. After all, I'm going to be using this for structured gen-code down the road. So if you guys want to build like buildings in game and you want to do the village building system, you know how like the villages spawn buildings, the for loop system would be really cool for that, because that's how Minecraft actually generates a lot of its buildings. It uses like several for loops, and which is kind of cool. Although I think they moved to a JSON system in 1.13. So let's see. So okay, so at the current state we're at, we can do the recursion, we can process the states, we can build the states, we can inject keys. We don't actually do any handling in this one, so the handle call is not run, which is what it actually turned the state into actual object. How we're going to do it is this is going to run, and it's going to collect all the elements, which could be bad for memory depending on how many of these you got. We're probably going to want to run some logging at some point. Yeah, we're going to want to run some logging. There's a lot of stuff that needs to be done, and I actually need to work towards doing a lot of debug systems as well here. One of the big things is from some of you that have seen when the game actually launches, I have a JSON debug window that pops open. I need to start putting timing information in there, so that way not only do I know what stuff is loaded, I know how long it took to load, so that way if I see one that gets extraordinarily high, and I can even put checks in there that go, okay, if above 100 milliseconds, mark as red, so that way it pops a very bright and red in my debug menu and I know something's wrong. And I could either wave it off as like, oh, my computer experienced a lag spike right then, or something else is going on. I can make it more intelligent. But yeah, so this is going to build the states. So this is going to build all JSON elements. And this would be load states from generated elements. Because what this really comes down to is you're generating element data from an existing structure system. And we still have to do the for each system as well. So I'm pretty sure the for loop works. And you know what? This is where we got to the point where I can technically move this to another object. So what we're going to do is we're going to come up to the JSON system in the core. Actually, I think we were just in there. No, yeah, this is part of the render system. So yeah, we can go in here. So we want to go to the framework. JSON, and I'm going to make one called struct, because that's kind of what this is. Not to be confused with, so we'll call it for loop, and what we're going to do is we're just going to copy this, and this method, put them in here, and we're going to make them static. And to be honest, these two right here can actually be moved to a different class file. They don't relate to the for loop in particular. I'm going to leave them in here temporarily. And then what I'm going to do is I'm going to put some notes here. To do move to shared JSON helper. Because this could be used by anything. Like, we could have all kinds of stuff that use these two. Because injecting values into a string, pretty useful. This one actually could probably go to my string helper, my coding lib. And this one, building a JSON object out of a template and injection keys, I could use this for absolutely anything as well. Particularly, I have that wiki builder that exists that does something very similar to this already, that I could go and put this in my coding lib and then recycle this code between not only Minecraft, but also my wiki builder, which builds websites and wiki-based websites. It's a program I actually need to finish here pretty soon. And this one we need to go if render state object.has. By the way, what we're using for JSON, for those who might be wondering, we're using the JSON library. I'm actually probably going to build my own down here eventually, because there's a few quirks about the JSON system I don't really like. One, it's designed more for annotation-based injection, which is kind of cool, but I don't use any of those features. On top of that, I would like to force my keys to lowercase. As you see, this is case sensitive. I don't like case-sensitive keys because it makes it just unnecessarily difficult for a user to work on. Not that I really want users to be doing things. Throw new legal argument exception. I kind of want to use custom exceptions here, but I'm not gonna. For loop could not understand layout expected for each, or I guess we're gonna call this data. And these are actually lowercase. Yeah, for each, yep. So that gives us some information here, and what we really just need to make now is a for each. And then right here we need to just make some checks real quick. So we're gonna go as render state data dot has start. I would do some really basic checks. So normally the JSON processor has this stuff built into it, but I'm trying to make sure that this is as simple as possible, because I might move this to my coding library, which is, by the way, for those don't know what the coding library is, it's a JSON based, no, not JSON, it's a Java based library that I use outside of Minecraft. So it's not just Minecraft based, it's for anything I make Java based. It's actually owned by me, so the organization doesn't have the copyright to it, I do. And it's anybody can use it, to be honest. It can be used for just about anything as well. My dog is sitting here whining because she wants my sandwich, which is sitting there on my desk. I always have the bad habit of, like, when I get a sandwich, I want to stream sometimes. Anyways, if we don't have either of those values, we want to throw a runtime exception. So runtime exception. You know, I don't have to throw runtime exceptions here, so for loop expects start and end values to be values in JSON object structure. So that'll kind of give some debug information what's going on, and we could say it throws an exception, but that really wouldn't help because it wouldn't get caught anyways. The main thing is what you want to do is you just want to make some information here and just go, okay, handles JSON for loops for generating JSON object data. This would actually be called do loop. Handles JSON for loops. To be honest, we also want to do like while loops as well, like while true or while something else, but we're getting kind of out of hand when we're thinking about doing all these data structures, because what we're doing effectively is making a programming language that uses data, and as much as I kind of like the idea of making my own programming language, it is kind of out of hand as well. So this would be current JSON object being read. Injection keys to insert into templates, and then returns list of objects generated. So yeah, it'll generate a list of objects, and of course it's a nested system, so this will be do loop. And then when it comes to doing the for each, I'm not quite sure how to handle it. Generate data for loop. And we basically need another method that's identical to this. That is for each loop. It's going to be a little confusing because, well, our for each isn't going to need a start and end. I was sitting here staring at like, maybe I need to copy the start and end, and I don't need to copy the start and end. My mouse's battery's running out of power. I decided to take my old mouse apart real quick and clean it, and it's still drying. Actually, it's still soaking in the cleaning solution. Yeah, I took it apart, and needless to say, the stuff that was growing on the inside of the mouse, because I know this mouse has been in existence for like a year and a half without being cleaned. I think it's been a year and a half. I actually don't know when I cleaned it last, but needless to say, it hasn't been cleaned in a while. So take it apart, really disgusting. Cleaned it off with rubbing alcohol, decided that probably wasn't good enough, so now I got it sitting in a solution of vinegar that is going to eat anything that's left alive on it. So this will be for each loop. And the for each loop is going to be run almost identical to the for loop. The only difference is it's going to have its own set of injection keys per loop instead of basically going through a for loop system. So this one, like, I actually have not been paying attention properly. We need to be building the entry each time. And then we need to be injecting a key for it. So We get our template. Make sure we don't break our template, by the way. So when we make the templates, by the way, we don't want to edit the templates. So when we come down here, we actually call build element. We make a brand new one, and we essentially copy its values. And then, of course, if we see a primitive string, we try to inject keys into it. So this would be inject keys in the string, and then this build element from template. So that doesn't look too bad. So now we just gotta handle this guy. So this guy gonna be pretty simplistic. I'm trying to decide if I'm handling the flow of this right too. So we get our loop, which let me go and find our data. So we get our loop and we go, say we find a for loop, we get its data, we pull its state, and then we inject into the state. So that sounds good. Sounds like I'm handling it right. So we get our data, we get our system here. Of course, we have the ID system, which is also in there. That allows us to figure out the name of the key. By default, everyone's going to be number. It's a little crap, to be honest. What we also want to do is we want to go, if we come down here, and if depth does not equal 0 and ID equals number, actually you can't do it that way. Dot equals ignore case number, and then we will throw another exception. And this one would be nested for loops must each have their own unique ID. So not to overlap with the default. This technically means that what we want to do is go back here, and we are going to need to ID this guy. And his ID is going to be frame, because that's what he actually is. And then we just come down here and we change this to frame. Not too complicated when we sit here and think about it. We're just our appending type and our first loop. Second loop is handling direction or rotation of the machine. And then we're doing our frame for this. This technique, by the way, can be applied to anything. This doesn't have to be a model, because what we're doing is a model, by the way. This could be an item. We could have different states based on metadata. And instead of you doing very complicated handling, you could do for loops to do all your stuff. So say you had thousands of states, that would work. It could be used on your block. Say your block had an animated face that went by. Although in the case of a block, it's less likely because Minecraft has a built-in animation system for icons, so you wouldn't need to do that. But say you did and you wanted to do a very complicated system. You wanted to switch textures based on states. You would an on and off texture, or say you had multiple textures, like a powered down texture set or something like that. You could do it via this system, and it would work. It would be really basic, because this isn't very many lines of code. So we go from 104. I believe we end out one more line down. So we go from 104 to 156. So it takes about 52 lines to do this. It would normally take this amount of lines per entry. So you say this is like 1, 2, 3, 4, 5, 6, 7, 8, 9. And that was 9 times, like, I think 200 and that's times 2 plus 56. Times 9. So you would need 2,000 something lines to do this normally. Even if you took the for loop approach, which I was using, so say we had this number of lines, you had 4 more to our previous, so it was like 9, that was 13, so 13 times 4 per rotation times 3, so it would have been 156 lines. We're still seeing a good reduction, because as I said, like, what was that, 50 lines or something? It doesn't matter. It's a reduction. It's a really good reduction too. So it's not even like a 50% reduction. Like we're looking at, the first one was 2,000. How do you do that again? So it's like 50. No, it would be 2,000. Like 2,000 times divided by 50. So it's a 40 times reduction in code usage, and the other one was like 150 divided by 50, 3 times reduction. So it's a really good reduction to have this system, even if it is a little complicated on the mental state to fathom how it works. And I mainly say that because this isn't user friendly. Like, this is crap. This would be nicer if I had like some backgrounds behind it or something, or it would be easier to understand, but with the nested for loops it starts to get a little complicated to understand what's going on. It's not a clean implementation. Theoretically, you guys wouldn't be touching this directly. If I ever made an editor for this, you would use an editor to do this stuff, which would save so much time. So what are we calling this? Oh wait, we're doing this once. This is actually for loop dot do that. And we need to actually name this something different, because it's going to end up causing problems if I don't. Because what happens if we decided to use that same name for like an Open Computers implementation of a for loop, which we would never have to do, but I mean, that's an example. We want to do generate for loop is what this would be. Of course, we would actually have another implementation here as well, so if we had a for each, which is actually our topmost structure in our object, we'd have a different implementation. So if this was a for each, and my note, you can only have one of these in the state system, so you can either have a for or for each. You can't have both. To be honest, you can only have like one index entry altogether. And this would be generate for each. And there you go. That's what those two look like. They're basically identical to each other. The reality of it is what I could actually have done is made some kind of object to store these up here, and I wouldn't have duplicate code, but I'm going to keep it simplistic for the moment and not overcomplicate it, something that's already overly complicated as it is. And yeah, next time. I was like wondering why that code looked weird in my head. That needs to be next time. So this is handled effectively. We don't have to touch this. So our focus needs to be on this, and what is erroring out in this file? Nothing. Okay. By the way, probably when we go to run this here, as soon as I'm done with this whole implementation, this is probably going to crash repeatedly because I've implemented like 5 or 6 systems now that need to be worked on. And why are all these erroring down here? I'm honestly confused. Okay, IntelliJ is just being stupid now. I hit build and rebuild real quick. IntelliJ likes to misbehave. So get all our data, we got our loop set up here. So I think all this is good. We'll probably JUnit this in a second just to confirm that it is functioning. Now we need to do our for each loop. This one's a little bit more complicated because we have to effectively build values, I think. Well, we don't effectively have to build values. So what we want to do is we want to make sure we have an entry for our for loop system, or not or for our values system. Our brain is getting a little confused here. I haven't slept much, so we'll see how this works. So we make sure we have the entry for value. If not, throw an exception because we can't run without it. We're going to just use our standard exception up here, missing value. So we go okay, for nested, or not nested, for each loop must define a JSON array of values to loop over. And this would be, as we said, a JSON array. Actually, what we would also do is, on top of this, we would go, not only as if it's missing, is if it actually, if we has a value, and we go is JSON array. So if it's not a JSON array, then we also do this. So it's like, hey, you must define this as a JSON array, not just like a list or something. I'm moving away from the idea of maybe doing split strings and stuff. Like there's a lot of that older stuff in the older JSON code where I allowed things like that because that's the way I did it. I'm moving to like it's more mandatory to use arrays and objects and stuff because that's kind of the standard of JSON. So we do a JSON array, values equals current JSON object get as JSON array, because you can actually directly grab it as a JSON array, value. Actually, I think it should be values. Let me check our object. Because I defined the structure, by the way, for this before we implemented it at all. That's a great way to kind of plan out your JSON structures, is go ahead and just make the whole thing, then define all your data. Unless you're in a case where I use injection keys, and then that's something that maybe you don't want to do. Anyway, so for that's going to be JSON element is what it's going to loop over. So element E values, and you can loop over this entry directly, which is really nice. I'm happy that the JSON system implemented iterable on this, because it does make life so much easier. See, iterable JSON element, so nice. So we got our JSON element, so we know what our element is. We want to go, okay, if e dot is JSON object. We're going to have 2 implementations. No, we're going to have 1 implementation. Yeah, 1 implementation would be easier, because I'm thinking I could use JSON primitives here, and what I can then do is say, okay, you can define an ID, but 1 implementation is a little nicer because it's not too much more work to add a couple more brackets in here. So we go that. If it's not, we throw an exception. So we go throw new run time exception. For each, values must be defined as a JSON object. Object containing injection key to value. And you can put multiple injection keys in all. My power just flickered. I hope I don't lose this recording. It would really suck. Actually, we're just going to use key to value because it's understandable. So I have a backup battery for this computer, might note this, but the power draw of my computer is too high to actually use the backup battery, so we're pretty much using the backup battery like a surge protector, which is kind of redundant. I probably should buy a bigger one. I could make one. I actually have the electrical knowledge to make one. I would have to brush up on it, of course, because I would have to do... I'd probably just buy the parts. I think you can buy ready built charging circuits and output circuits offline, and you can definitely buy the batteries. So those batteries are like $1 each, and I think I would probably need about 200, 300 of them. I don't know. I think I've seen people get away with less. Okay, so in here, we just pretty much want to go over an entry set. So we'll have JSON object. We're going to just do O because I'm lazy. Get as JSON object. And this would be... Oh, whoops. We are not programming in... I forget what language does that. I've been programming in way too many languages recently. I gotta go pick up C again here, the back end of this week now. So I gotta go back to programming in, not even C++, literally C. And I've only programmed in basic C a few times. I'm more familiar with C++. It's gonna be a little painful because I gotta do a piece of software for that at the end of the week. And that would be for a class, by the way. I don't do freelancing in languages I don't know. So let's see. Yeah, this would be an entry set, so this would be JSON. No, it's going to be a key set. Entry set, yep. And we can probably bounce directly to that and then just copy that part right there, which I love so much. I like it when stuff is actually defined. And this would be entry. We got an extra bracket there. Okay. Nope, still not. Still complaining. Unexpected token. Map entry entry. Oh, because no, that's right. O.entry set. What is it not liking here? It clearly understands the no, it doesn't understand the format there. I'm pretty sure that's the right. That's an iterable. Hold on, I don't know why that's there. There it goes. I flat out don't get it when IntelliJ does this sometimes. There's nothing wrong, but it's like, oh, there's something wrong. And I think it's where it's just, there probably was a processing bar down here and I wasn't paying attention of where it's actually telling me it's doing stuff. That's the Scala compiler. There's another bar that usually runs down there that tells you when it's compiling. But IntelliJ's been acting up more and more. I probably need to update again. I probably definitely need to stop downloading beta versions. I think I'm running a beta, or that's why I don't like updating my environment, because if we're running a really new version, and I think I've been running on the 2015 version for like the longest time, and I finally updated. And I don't really like the new update because, well, not because it really changed anything major, but there's certain subtle changes. Like, I used to be able to right-click and import a dependency if I was missing it. So if I need to use JUnit 4 or 5 or so I can go ahead and put the import in there, and I can go, okay, right-click, add dependency, and I can pull that dependency in from IntelliJ itself, because IntelliJ includes its own dependencies for that. Now it's like, you're not a Gradle project and you can't do that now. And I'm like, really? I have to be a Gradle project to do that? I don't like importing Gradle, by the way, into IntelliJ because it auto-downloads dependencies. I store a lot of my dependencies locally that I use. Luckily, I have them all locally, so all I had to do is go open them to find them. So when we're iterating through this, we got our entry set. We need to take our entry set, add it to our injection list. Well, this is complicated. We're effectively going to have to loop through our entry set twice. And this is where I'm going to have to just do something like this. I hate making just data maps whenever I want to. So first things first, string value equals entry dot get value dot get a string. I'm just like literally going to give no craps about this, and then we're literally going to go new keys dot put entry dot get key and value. You know what? We're going to be even lazier, and we'll just put this here. The only reason I'm not really checking to see if the entry is a primitive is if it's not, it's just going to turn it into a piece of junk, and that junk is then going to turn around and make the JSON just not work. And you'll see errors flow down later. Oh, well, maybe not. We gotta check, because I'm building this system for people who don't know how to program, and if they don't know how to program, that means they also don't know how to do proper data management. And if they don't know how to do proper data management, is JSON primitive. So primitive will give you goodbye pretty well, because you can convert any primitive to a string, so you don't have to worry about that. And then we just do our else statement, and we just go, you fucked up, and throw an exception. So for each values, keys must be JSON primitives. That should get them at least enough information that they can Google search and figure out the rest. So we get all of our keys, and then we want to come down here and we want to go, okay, injection keys dot put all new keys. Then we would go states dot add build from template. We're gonna need our template. This is where things get interesting, because now we have to handle this bullshit right here. And this is where I might segment this stuff out here real quick and make another method. So this will be public static list JSON object. We're just going to call it handle at this point, just because I don't have a better name, and that extra P is not helping. Okay, so we're going to need to know what our current object is. We're then going to need to know our depth, and we're going to need to know injection keys. So basically everything that's up here, we have to pass in. We're going to need to know our start point. So int start, int depth, or int end. Okay, so then we're gonna have to do an ID system. So string ID. So what we're gonna do is we're gonna go, okay, if ID does not equal null, because we're gonna say if we don't give shits about the ID, and then to save myself some pain and effort, we're gonna do a magic trick here. By the way, if you're ever comparing strings and you don't know if your data is null or not, use this technique. It's really nice because that value cannot be null because it's a thing, and that saves you time. So we're gonna need our states. Good cool thing is I can actually take this down here and do that. And what we can do is, we can't get away with it. Okay, so we actually have to do this. The reason we got to do that is, man, I don't want to generate a new overlay list every time we're doing this. Let's actually start to be a little bit more intelligent about how our structure is. And we're going to start just passing in a list and populating the list as we go. This will save us from having to rebuild that object every time, and we're just going to do this on the entire structure because it actually is a more effective system. Efficiency, maybe not huge much. But well, actually, it's more efficient, maybe not more effective. Details. There's a reason why it's better. It's just I can't exactly explain the reason because, well, I'm probably don't actually know myself. So we get down here, and of course now we want to make sure that we actually are calling systems. Actually, wow, that took a huge chunk out of that code, reusable code. So states, injection keys. Then of course this is going to want start, end, depth, +1. No, actually that's our current depth. Then we want ID. There we go. And we just got to pass list in. So I believe list goes right here. Or this would be states. Make sure I actually fix that. It was previously called state, but now I'm going to change it to data. I have a feeling I'm going to have to go through and like rewrite some stuff to make sure this loads. I have a feeling I might want to add some kind of legacy support here. What else are we missing? I don't think we're missing anything else. So we got our handle method here. So now we get down to the generated loop. We put all of our keys in here, and now we just literally want to call handle because this will do all of our work for us. Injection keys, ID. Oh shit, we don't actually want to loop. I thought I was being clever by making this. This won't actually work. And the reason why this won't actually work is that we're already looping in here, and we can't loop again. We can trick it. Actually, hold on. We can trick it. It just occurred to me. Because we don't... Yeah, we... Oh, that'll work. So we would do null. It's just this will be really stupid because we're just kind of wasting time. But it'll work simply because if the start and end times are the same, I'll go I equals this, and okay, if we're less than equal to that, we're good. It's going to iterate up one, and it's going to stop. It's not going to run again. So it runs its loop just once. We don't do our injection keys, but we already... feels kind of wasteful. You know what's actually more wasteful about this is the fact that I'm doing multiple loops. Let's get rid of this part. We're going to take this. And then we're going to do our key thing here up at the top here. So we're going to do our loop here. Then we're going to do our ID thing here, which is not going to be null, so I can get rid of that null check. So this gets rid of this part of it. Which will come back down here, we'll get rid of ID as well. Now we still actually need ID. if number dot equals that wouldn't work. No, that would work, because if our depth is greater than our... I'm going to get rid of this check because I don't like it. It does exist for a purpose, but, you know, actually, hold on. I can use it, it's just in the wrong spot. So what we're going to do is we're going to come back up here, and right after I do ID, I'm going to go, okay, if depth does not equal that, and we're still using the thing number, it's going to crash. So let's just get rid of the ID out of the list. Let's just get rid of all this. We can still use the handle function. We can get rid of all this crap. Get rid of the injection system. Because what we're doing is we're pulling our template right away, and we're using it as soon as we pull it. And because we're pulling from the same system over and over and over again, it should work. So object system depth, and then up here, that works. And then now what we also need to do is injection keys dot remove. Oh, can we not? There's not a remove all? I could have swore there used to be a remove all. Okay, so there's actually not a remove all call. I could have swore there used to be one, but I might have not been paying attention. It's a common mistake. So new keys dot entry set string, and we just gotta do this the hard way. Oh wait, we can't do that way. No, actually we can. We're not editing our actual key sets. So injection keys dot remove entry dot get key. And actually, you know what I can do is I can make this even simpler. String key and key set key. Because we want to clear our data beforehand, because for all we know there could be a special way we want to do it. Theoretically, in the best case, we want there always to be the same number of keys in each value list, but I'm not going to check for it, and I'm just going to remove it and clear it, and then I'm going to let somebody figure out their mistakes later. So this looks good. Good. Now we just got to update our render data, and we should be able to test it now. I'm just going to do like a live test, not actually going to do things. And what we're going to do is we're actually going to make this a little fancier. And we're going to go, okay, if elements doesn't equal null, else we do things. And that gets rid of the need for that. Actually, we're going to do a new array list here, so we're going to have to do if not empty. If elements dot is empty. There we go. So if it's not empty, we actually do something with it. If that not, we then do just a normal handle on it, because that means either of these calls didn't get checked. And this is going to be elements. And same here. Elements. And that looks pretty good, actually. So this will probably work. And this means we can actually, if we ever want to and come down through later and we want to do a while loop, we can do a while loop. Even though I can't think of why we would do a while loop, because actually we want to do an until loop. The only other loop I can think of instead of having a for loop would be an until loop. That means until the point. We could do other sub-variants of that too, but to be honest, an until loop is just a for loop that has a slightly modified change to its endpoint, and it would be really easy to implement but kind of pointless. So now that we've wasted 50 minutes coding, let's actually try to see if the game runs. Sorry for the pause there. Decided I wanted to take a bite of that sandwich. Really good tasting sandwich. Even though it's a piece of crap. By the way, this is what the belt looks like that we're going to try to render. I am going to have to do some modifications to remove these lines here because they're not used. Actually, you know what the biggest thing is? I don't even know if our modeling system has handling for loading technique models, so we're probably going to crash simply off of that. Like, nothing else is going to crash us, that will crash us. Actually, I'm not sure. It might work. A way for us to actually check this. Not that one. Actually, we're going to go assets here. Oh yeah, okay, we do define the model type at the end of these. I was trying to think of, like, do we define the model type? Because if we define the model type, then my engine loader will load it. I use a separate model loader, by the way, from Forge. I really shouldn't, but I do. It's a good thing I do, though, because that means when I go to transition fully to 112 here, when I mean fully actually getting Volt Engine running, I don't have to worry about Forge's own model systems competing with mine, and they'll work. I think. I'll have to look into that. It also means I can also take code from 112 and bring it back to 1.7. I shouldn't have problems. By the way, this is that data thing I was talking about, and we crashed. Oh yeah, we would crash. Oh yeah, we totally failed to load the tile entity, which means that has to work. As I said, we're gonna probably crash a lot. So it said it failed to find. Hold on, let me open that back up. Oh, we didn't even hit debug. Did we hit run mode? Oh, we did hit run mode. Failed. I was hoping I could actually click that link and I wouldn't have to go see if it was in the right folder. Content. So we're working on belt, and there's our belt. I just noticed you're in the wrong folder. No, you look correct. But I screwed up. I think I know what I did. Yeah, I decided I was going to put you in a subfolder, and then I forgot about that. Yeah, we're gonna need to put you in a subfolder. I plan to have, like, I don't know how many different types of belts, so we'll probably have like at least 6. So I want to make sure these are in the subfolder. And all I have to do to fix this, by the way, is go run code generator, and that puts it in the right folder. So this way it'll actually launch properly. Go ahead and let that launch, and this should work. By the way, for the people who haven't seen the code generator, it's like a really cool system where I can just generate a text file, or yeah, it just generates text files which happen to look like code files to handle things. And actually, why is that there? Probably shouldn't be there, but it's there. But yeah, it generates an empty file because there's usually when you're wrappering things, you're supposed to use them a certain way. I'm going to be probably doing away with the wrapper system on a lot of tiles just because they're not necessary. And we'll probably move to a little nicer system. I mean, I'm still going to keep the wrapper system because there are cases where the wrapper system actually is usable. It's just in this case where we don't actually use it, we're just kind of wasting file space. And there's a way around it, and I just have to invent that way around it. Oh wait, I hit debug on the wrong thing. So I've been sitting here talking, thinking it's loading in the background. It's not. My bad. And we'll toss a piece of sandwich at my dog so she doesn't whine. Haven't fed her yet today, but she doesn't get fed till like noon. Although she's probably been fed treats all day. So my mom has a bad habit of giving the dog a treat every time she leaves. So if she just goes out to take the trash out, dog gets a treat. If she just goes out to warm her car up, dog gets a treat. And then when she finally leaves, dog gets a treat again. And she wonders why the dog can physically be rolled around like a bouncy ball. Oh well. Let's keep working on this though. So I mean, we got it all set up. Theoretically, it works. We're dry testing it where we haven't like done anything to make sure any of this works. Probably if it crashes really, really hard and we can't determine why it's crashing in the middle of the system, I'm going to run some JUnit tests real quick. They won't take very long to make. And you guys can see what it looks like to JUnit test a JSON system. We have a few, by the way, like all the armory gun stuff is JUnit tested. That way we know if the data file is loaded properly or not. Now whether the data file is actually loaded at the end is a different story, because the JUnit test will simply tell you if the file can be parsed, not if the file will load. So you could have a problem where the file loading system doesn't work, although that's actually JUnit tested too, so it will be really rare if it breaks. I have not tested it on Bucket. So far I have been told it does work. And once again, we're back to seeing the data system. This is what this is, by the way. You can hit load, reload data. We're not deep enough, I think, in the phase. Oh, here we go. So this will actually show us things. Given the data is not very clean, I haven't actually got through and fixed this. The main thing we were actually looking for, I believe, is render data. Here we go, render. Yeah, you can see all the render types loaded. Now we can't see the states. The states is actually what we're doing, but there should be one in here for assembly line now, if we didn't crash. I need to make sure that stays open. It doesn't like something. Oh, I forgot to edit it. I made a correction in my design, and I forgot to correct it in here. So we're no longer going to define the type. I was originally going to define the type so that way it made sure it loaded the data correctly. Now I don't really care, as long as it can be turned into a string. That's all that matters. Because the final system knows how to turn things from strings into numbers and stuff, so as long as this down here turns into a number, it doesn't care. And we'll go ahead and debug that again. We're getting there. I mean, it's at least running. That tells me that it got through this first part, and then was starting to look at these guys and couldn't figure out what the hell to do with it. Actually, you know where that got? That got actually down to here before it crashed. So that means it made it through the first two loops and then crashed. That's a really good sign, actually. That gives me hope that we may not have to fix anything, and I can put the JUnit testing off to later, because I'd rather avoid JUnit testing if I can. Because it's a lengthy process to JUnit test. I gotta make test files, I gotta load the test files, I then gotta sit there and make sure that every part of the test file works, not just like some parts and stuff like that. And usually when you implement JUnit testing, you gotta do a lot of extra work on top of that too. So I end up having to go through this nice and beautiful file. I know it's not really beautiful, but you gotta go through here, and you may have to start breaking it apart. You might have to go, okay, put this check into a subcheck and everything else. That way you can JUnit test your subchecks. Though I probably won't actually do that particularly. There's like a whole mindset about how you can JUnit test things. I think we actually got loaded this time. I hit run instead of debug, I believe. Oh no, there's the thing. I was about to say I wasn't seeing my debug window. This doesn't load very well, by the way. That's the reason why there's a reload button up here. Is this tendency to break, and it's I'm blaming Java on this one, not me. Because I'm dumping data into the list, and Java's supposed to automatically resize and display, and it's just absolutely failing. Of course, we can hit reload and we can see this. This is all the output data that the JSON system spits out. This also gets spit in the console, though it's going to be changed to no longer spit in the console here eventually. Oh, we crashed again. We're making it further and further each time. For loop could not understand layout. Expected. Okay, you expected something, but then you got something else. Okay, so what happened here? Oh, I know what's up. You must be changed to that. It's working though. I mean, we're getting there. I still think I need to put some legacy support here because the texture loop system down here, I believe, if we can get down here, it looks for state as well, so because I want to be able to use the same exact system for the texture system here, because actually the texture system would get more use than it would get for render states. Especially the for each system. That would be really useful. I think I'm going to have to add legacy support. If this crashes again, we'll go ahead and fix it. We're getting there though. Once it loads though, we're going to call it, even if the tile doesn't render properly or we crash for another reason. As long as the for loop runs, I'll call it good enough. I'm going to try not to hit my microphone again with my hand. The only problem, I got this microphone moved in a weird spot now. And it's just slightly above the arc my hand normally makes to go to the keyboard. Probably have to move the mic again. I can't think of a good way to mount this mic. Like right now I've got it mounted to a wire shelf to the right of me. And I can't really mount it to the wire shelf to the left of me because that's where my other monitor is right now. Although I would have put a monitor to my right too, so I gotta figure out a solution to this. Can't really bring it off the top of the monitors because one, that uses a clamp that probably would break the plastic on the edge of the monitors. Oh well, anyways, I'm getting distracted. Our main thing is we want to focus on this stuff. Let's see. I like how well this runs too, considering this is like technically multi-threaded. And I've yet to have the GUIs crash on me. Unknown number, yeah. Okay, so something about our template system didn't inject properly. Because we got yaw right here. So when we actually go through our loops and we go down to here, we should build from template. And it goes is string, inject values, should it actually replace yaw. That should actually work. So we get down to a point here where it doesn't. Number format accepted. So it actually made it all the way through the loops and actually did work. It just didn't inject. So s.replace entry.key. I don't want to sit here and like stare at every one of these because we run a lot of injection calls. I mean, we run a lot. So what I think I can do, put a debug line here. And what we can do is we can go, okay, if... No, we don't want it that way. We want it right here. And we want to make... If value equals... Actually, can I do... oh, shoot, you can do that? I'm impressed by what IntelliJ can do sometimes. So we want that line to work. So we want to know when yaw gets passed down in here. Actually, no, we don't want to do that. Hold on. I have to make a key for that too. Entry... No. s.contains... yaw. So I want to know when like our string contains yaw. That'll work. So run and we'll debug and we'll test it again. You know, I might just edit this model and get rid of those. Because what, by the way, what the original reason were these for was to do like piston heads above here and stuff. So like you could have an item come through the belt and then have a piston slam down and convert the item. I did actually early prototypes of it and I know it does work, but all the machines we made to put up there looked like shit. Was a good way to put it. Probably build custom built machines for it. I don't know. I'll leave them in there and I'll probably just disable their renders. So I know what they are, like C1, 2, 3, and 4. Actually, yeah, what's 1, 2, 3, 4? And then how we get rid of those is like what I will do is up here on the base here is I'll add an exclusion list to exclude those pieces from the render. I mean, because if we end up making piston blocks like that, which I doubt we're going to end up doing, especially since I might just do machines for everything like that. I know I said like on the comment section for assembly line that I probably wouldn't do black box style machines, but I might do a couple. just because rendering everything is a little tedious. But then again, I kind of want to render everything because it would look nice. Imagine like watching your conveyor belts, and then you would see the physical arm come down and press the metal down. I mean, it'd be a lot of render work to get done, but if you got it done, it looks so amazing. I mean, that's one of the things I'm trying to head with the assembly line is I want to get really high render detail out of things, and we're not talking like high graphics. We're talking detail. The two are separate from each other, because most people go like, oh, but you're doing detail, that means my frame rate's going to tank. No, it's actually not. Your memory you might need more memory to run the pack, but the frame rate won't change much. Because what it'll be doing is it'll go through, and it'll be going through several states. So we're doing the same thing we're doing right now. We'll have frames, but the frames would be either models or a collection of model pieces. So you would just have, okay, our next frame we move the piston head down by another percent, and so on and so on. And then you would have the ingot, which would change or deform, and that could be very simple as we're rendering a box that we're changing the height every so many frames. And of course this would all be baked and stuff as well. So like a 112, actually 1.8 plus it would be baked. 1.7 I might implement a baking system to save frame rate. If it's not, it doesn't make too much of a difference. Because effectively if you're just rendering boxes, they render pretty fast. Go ahead and close this so we don't care about that. I'll probably come up with a system so we can display all the states here later, but I gotta do a lot of GUI work for that, and that might not happen right now because there's not really a need for it. Or I might do some more, double click the entry, and then it'll pop up GUI open, and then you can see all the states. I take it by the fact we made it to phase 2 that we haven't crashed yet, so that's good. Or bad. Because all of the texture should have been loaded in phase 1. Did we hit a break line? I just haven't noticed. No? We are processing renders. We are in simple bell. I feel like we've hit a break line, or that, or it's just because I'm trying to run that debug line check. It's just taking longer. We crashed, so my my debug line didn't work. Yeah, my debug line didn't work at all. That tells me either this is shit, or we're not making it down here. I don't want to... Well, you know what? Actually, I wouldn't have to wait very long for this to run. So we're going to hit that point here. I don't like how there's not a check mark next to that. Why is there not a check mark next to this? I run debug mode. And the reason why I'm concerned is there should be a check mark box through here. I'm going to hit close. And I'm going to rebuild the entire game real quick. Build, rebuild project. And while I wait for that real quick, I'm going to go see what that YouTube comment was I just got. Probably should ignore it for this video, but eh. Yeah, somebody was impressed. So I made this video of a pie chart, by the way. I'll turn the audio off and I'll show it. So I made a video of how this animates. This is built-in JavaFX feature, by the way. And a lot of people have got really impressed about it because they think it's amazing. I didn't write the code for it, even though I can write the code for that. I actually could have made that. But people are like, oh, that's really cool. I've got quite a few comments from people that are impressed by that. But it's not my work. Although I'm going to link him the code to my system anyways, because the guy's like, oh, can you send me the code? If I can find it. Oh, there it is. Okay, so we finally rebuilt everything. Then we want to launch debug again. I still am not seeing check marks here. What gives? Enabled conditions, like done. When you see it like a, there's no check marks through these. What I suspend all. Did I accidentally turn the debug lines off? I forgot. I actually have debug lines down here that I've got turned off. So they're turned on. And it's like you can see him here. I mean, they're working. That's clear. Okay. Man, it's really hard to determine how far we are making it through the load phase because all the textures should instantaneously load. So like at this pre-initialization phase, everything should have loaded. Yeah, we make it all the way to phase 2 before anything happens. Oh, we hit a break line. Okay, so that's good. So what we're waiting on is I'm waiting on this line to oh, what? I gotta get every string. Okay, we're down to our first type line. Hold on, I think I know why this isn't working. Yep, I know why it's not working. So there is a slight problem with how this does behave. It does not do nested objects, and I'm gonna fix that. So Boolean do nested, and in some cases we want to do nested, like this one we want to do nested. Everything else we do not. And the reason why we don't want to do nested is we really want to process some of these lines only after we've collected all the keys so it gets more efficient. But down here, like once we hit a data point, we want to actually go through all the nested behavior. So we want to go, okay, else if state dot, wait, actually let's do this. Hold on. JSON element value equals this. We'll set to the final because we aren't editing any values. So sometimes a good idea to make sure you are actually doing some of this stuff. And you know what, the thing is you can actually just call getString on this. I want to actually know if it is a string. Not that I don't want to call getString, because this thing you can call getString on the values. Anyways, else if value instance of JSON object, and we got to make sure we actually handle a couple different things here. I think the only actually other thing we have to handle is an array. And we want to make sure public static JSON element build from templates JSON element and then we want this and we want to change this to build element, and we're going to change this to build object. The reason I'm making a difference between these is somebody might get confused that these both do the same thing, and the fact is they're not going to do the same thing. I'm actually going to change this to be this guy down here, and the reason I'm doing it this way is I want to be able to handle a multitude of different objects, and we also want to be able to do this JSON object. Actually, hold on. add key, add value. So we get our value here. Okay, so what I want to do is I just want to do this. Return. And then we just want to return... actually, what is that? So I was returning JSON, just give value. Ooh, I don't like when we're adding entries. Can I copy an entry? So I'm going to do value.copy. Clone. There's no way to clone it. So I guess we are just going to return it if we don't know what it is. We should never get down to this point. But we're going to come up here, and then what you would come up here and do, you would do state.add JSON entry.get key and build element value injection keys. So that's how we're going to do that, and this means we can actually put this back down here now because we don't care. So we got our primitive. And what we're going to do right here is we're actually... Why is this misbehaving? Technically that's everything else should flow to that. My dog is... Like, this dog will sit here and watch me, and if she doesn't see me eating my food, she'll immediately start begging until I toss another piece of food at her. It's a really bad habit to feed a dog this way, but also kind of gets on your nerves if you don't. So we gotta make another JSON object. So what we want to do is we want to return build object from template. Our template is going to be value dot get as JSON object. So that's our template. Injection keys, and then we're gonna have to pass do nested down. Do nested. And we may have to pass an index value onto that, which I don't want to do. We're just going to just do nested because I don't think there's going to be a worst case scenario on this. Anyways, JSON array equals value dot get as JSON. No, I want to get as JSON array, not whatever you tried to put there. Like, I type the full word get out, and now immediately it switches on me. JSON element array, and this one we're going to return. Oh, we're not going to return. We have to make a new JSON array. So this would be JSON array clone equals new JSON array. And we effectively want to clone dot add build element from template element. And then we need our injection keys. This is something that is definitely going to need to be JUnit tested at some point, but this should handle all types. I don't like how this works. I mean, we can technically pass down around JSON primitives without a problem, because this is what this is a JSON primitive. But hold on, is there like a catch-all for this? There is. Set value primitive. Set value. You guys all literally go to the same thing. Okay, I can't call you though. So this has a restrictive type set to it. You can do a Boolean number. It's a limited typeset though. So I'm going to try to make this more efficient. We're still going to leave this down here because I don't know what the hell that is. So, and what I mean by that is I don't know if there's anything else that could possibly end up at this spot, because the only data types I know exist are an array, an object, and a primitive. I don't know if any other object types that exist for JSON. Anyways, we go is string, we go else, if value.isNumber, we handle the number value. Numbers are just, we're going to clone it because we want to make sure we are copying and we're not actually using the data. This will be value.get that's number, and we're just copying it that way. I don't understand why Google doesn't have a copy feature built into their thing, because you would imagine you don't want to mess with data. So it's Boolean, and this would just be get as Boolean. The cool thing is, by the way, you can basically turn all of these into a string. So if I really wanted to, I could convert it to a string and then just pass it in, and I wouldn't care. It should cover everything. If there's anything that is not a Boolean number or string, I don't know what it is, because everything should convert. Actually, I think there is one other type I'm missing. So this is number. I think it's like there is like a big integer. No, actually, is a big integer considered a number? It is. I like how Java stuff is set up so nice. That's cool. This all looks nice. It looks like it'll work. So this should fix the problem. And it should load properly this time. And then I'll do the JUnit. I might make a video of me doing the JUnit this time. We'll figure out how that goes. I'm already on like minimum hours of sleep as it is, and I kind of want to push it and go all day, and I want to go all the way to midnight, but I suspect in the next 2 hours I'll just pass out. That's generally how it works. At least I got decent music going on, even though I just noticed the G is cut off on that. Let me fix that. Oh no, it snapped. You guys are gonna have to be without the bottom of that G. I kind of blame whatever software is rendering that though, because when I go to actually work on the collision box to move that string on the stream, or not the stream, the recording, the G is outside the collision box. That's I think it's a failure of the rendering software. At least in my experience, because I have that game engine I'm working on, or was working, I haven't actually touched it in months, that it put all the characters inside the collision box for the string, because I actually could take my strings, I could use them as actual entities you can collide with, which was kind of cool. So you could be jumping around and all of a sudden you would smack your face into the G. That was kind of entertaining when I accidentally did that. Accidental to collision box. Probably the weirdest thing I've said all day. I just realized that. Oh, it's like you accidental a complex system. Then again, I made a missile that shoots swords, and that wasn't accidental. More, I mean, it was intentional, but it's like that. I don't know how to best explain that. How that's an accident. Actually, I know. It's not the missile that shoots the swords that's the accident part of it. It's I made a perfect 3D render system now for fragments. You can render any block as a fragment now, and it works really well. And that was accidentally done. Frame, stuff. Oh no, we should be seeing should have been seeing something else in that list. Oh, we see y'all. Now there's gonna be a lot of like keys in here. Oh, well, there's only 2 keys and we made it to y'all already? I'm confused. Of course, I'm not gonna get my data at any given point here. Okay, I'm gonna end this, and what we're gonna do is we're gonna have to manually go through the top of this all the way to the bottom. I don't like doing it that way, but It's about the only way we're gonna figure this out. Actually, I have a better idea. I'm gonna go ahead and cut it here, and then I'll make a demo video of this actually working so you don't have to watch me debug all day. So I'll see you guys later.